Hi there! If you are watching this video, you've reached the final week of the MOOC, Next Generation Infrastructures. Well done! You're nearly there. This video reflects on your discussion regarding week 6. Again, I was very pleased about the high level of the discussions you're having. Today, I'd like to address 7 topics. First of all, the scheme from Bourgogne, introduced to you in section 6.1. Secondly, the need for redundancy. Third, the mismatch between complex systems theory on the one hand and key performance indicators on the other hand. Fourth, an unobserved contradiction, competition laws and the need for discussion and cooperation in complex systems. Fifth, the issue of incrementalism in decision-making in complex systems. Sixth, complex systems and strategic behavior. And finally, using variety instead of reducing variety. Donna77 asked a question about the scheme posted under section 6.1. He or she was wondering how to use this chart. For clarification, first of all, the graph is there, not for actors to use, but is there for the analysts to better understand the system. There is no best state or quadrant in the graph, but it depends on the institutional conditions and the observer's position which situation is most desirable. You'll find that, for instance, an organization that needs to be very resilient to unexpected events or requires a large degree of professionalism is likely to prefer a situation where its bottom layer is largely self-organized and has a large adaptive capacity. Another student was wondering whether adaptive capacity was governed by resilience and how risk management would relate to the graph. I would say that resilience is a value, which is acquired by having a large degree of adaptive capacity in the system. Risk management is just one of many tools which can help you determine for which kind of risks you need adaptive capacity. The second topic of discussion is the need for redundancy. Carlos was wondering about how you can deal with the fact that failures are bound to happen in complex systems. The answer is that there is a need for redundancy. If a service is so critical that it may not fail due to a failure in the system that provides it, redundancy can be the answer. Think, for instance, about the emergency aggregates in place at hospitals. The third issue I'd like to address is the mismatch between complex system theory and key performance indicators. Key performance indicators are used to assess the performance of a system for a length of time off, for instance 5 or 10 years. Assessing the performance of a complex system is, however, difficult because of the system property called emergence. The reason for this is that KPIs are static and often can't include unexpected developments. Take, for instance, the fixed telephone network. In the past, these copper lines were only used for telephony, but nowadays they are also often used for other services, like the provision of television or internet. KPIs would not have been able to incorporate these extra benefits that the lines now offer to their owners due to innovation, which makes time incompatible with complex systems. The fourth topic of discussion is a contradiction observed by Anachitna. He or she justly points out that competition laws prevent cooperation and discussion among actors active in the sector to prevent collusion practices. However, often cooperation and discussion among actors in complex systems is necessary for the system to move forward. For instance, in interoperability issues where standardization is required. To manage this dilemma between the need for cooperation and discussion and the undesirable danger of collusion in the sector, there is a need for a strong regulator that has a soul. Like Ignacio Perez Arriaga pointed out, this regulator should think further than just applying rules and just his discretionary room to facilitate progress in the system. The fifth topic of discussion is the issue of incrementalism. Complex systems are often characterized by incremental decision-making and incremental progress. This is necessary because a grand master plan often doesn't exist because of the unpredictability of complex systems. Percy C. Migo, however, points out that in developing nations there is often a dire need for radical change, and there might be no time for incremental change. The answer to that is, although it is not common sometimes, if the conditions are right, infrastructures can move forward at a very fast rate. So if the need is high enough and the policy window is open, yes, radical change is possible. However, then there will be no guarantees that the result acquired is also desirable in the future. Wondu often also raised a discussion point regarding incrementalism and resilience to major disasters. He or she asked whether or not a system that is governed by an incrementalist approach is susceptible to adverse, high-impact events, such as, for instance, natural hazards. The answer to that is complex. Systems are almost always susceptible to unpredictable, disrupting events. However, when mere hazards or actual hazards occur, the system is often no longer governed by its usual governance bodies, but a policy window opens up for crisis management. Crisis decision-making is capable of quickly and decisively directing actors, which will allow you to quickly recover from these adverse high-impact events. The sixth topic of discussion is the connection between strategic behavior and complex systems. Complex systems often invite actors to behave strategically because malicious actors can hide their true intentions in the midst of complexity. By staying under the radar, meddling in the margin will often go unnoticed, or the system will develop so quickly that the actions of malicious actors are quickly forgotten. The seventh and last topic of discussion is the need for utilizing variety. Heinen was wondering whether it is better to reduce variety in complex systems in order to reduce the complexity of those systems. My answer to that is that reducing variety occurs by utilizing variety. Letting a system self-organize will allow the best option to emerge out of a variety of options. This best option can then become the standard, yielding the best performance or perhaps enjoying the highest level of public acceptance. I have enjoyed reading through your contributions, and I was especially sparked by a comment from Ion Fuad. He or she and students reacting to this thread just realized that if you are living in a country where infrastructures are available at a high quality level, you may count your blessings. Good luck in designing policies to better manage complex systems.